Hey there, welcome to Math Time with Ms. B. This is where I show you examples of concepts, break them down, and help you see that math isn't such a scary monster. I post a problem a day, so like and follow and keep coming back to see what's going on. Remember to leave a comment if you have a specific question you want broken down or want to see more examples of this kind of problem. Today we are looking at multiplying rational functions, okay? We're going to zoom in and see what we got. Remember that the steps are always going to be on this right-hand side, and then I'll number them as I do the work on the left, okay? So we're going to break this down. When we multiply fractions, we are going to multiply exactly like we did fractions. The rational expressions work the same way. If you need a refresher on that, I have a video on multiplying fractions, okay? Before we get to the multiplication process though, we are going to factor each one of these pieces, okay? If you need a refresher on that, I have a video on factoring as well, okay? So let's first take this x minus 8, okay? There's nothing to factor there, so I'm going to leave it alone. I'm just going to rewrite x minus 8, okay? For the denominator, when we have this leading coefficient of 1, we can kind of factor it in our heads a little bit. We don't have to go to the box method or anything like that. We just need two numbers that multiply to equal 40. So we're going to multiply to that, and we're going to add to equal -3. Okay? And in this case, that is going to be -8 times a +5. That gives us our -40, and when we add them, -8 plus 5, we get -3. So that's what we want. So our factors are x minus 8 and x plus 5. Okay? So now we're going to take a look at this second fraction. Okay, and this second fraction is, the numerator is nice because this is what is called the difference of squares, okay? We have a perfect square in x squared. We have a perfect square in 25. So these break down to be x minus 5 times x plus 5, okay? Over x minus 9 can't be broken down anymore, so we're going to leave that alone as x plus 9. Okay? This right here is step 1. All that is step 1. Okay? Step 2, we're going to take each fraction individually, and we are going to simplify it, cancel anything out that we can. Okay? So for my first fraction, I have an x minus 8 on top and an x minus 8 on bottom. Okay, remember, if you cancel everything out of your numerator, you're still left with a 1 on top. Okay, don't think that it just magically goes away. For our second fraction, there's nothing here that's in common with both the top and the bottom, so we're going to leave it alone. So we end up with 1 over x plus 5. Okay, times our second fraction doesn't change anything. It's x minus 5, x plus 5 over x plus 9. Okay, so this right here is step 2, where we simplified what we could. Okay, step 3, we're going to smush everything together. Okay, we're going to smush everything together. So we're going to do numerators over denominators. 1 times x minus 5, x plus 5. So I have x minus 5, x plus 5 over, and we're going to smush together all of our denominators. X plus 5, x plus 9. Okay, we don't want to FOIL these or multiply them in any way, because then we're just going to have to undo all of that work to simplify again. So it's better if you just smush them all together to do the multiplication process. So this is our step 3. We multiplied everything together. Okay. The last step of this problem is we are going to simplify one more time to see if there's anything we can cancel out, and there is. We have an x plus 5 in the denominator and an x plus 5 in the numerator, so those cancel out. So we're kind of left with this guy right here, all right? That ends up being just x minus 5 over x plus 9. That's our ending answer. That is our step 4 when we cancel that again. Okay, that's it. Let me know if you'd like to see more of this. Again, comment below if you have a specific question or concept you want to see on a future video. See you later, and remember, you got this.